Okay folks, we're again looking at the vertical transformations for cosine. We're sketching over the domain minus 270 to 270, so you cannot go past those two lines on the diagram sheet that we're sketching on. Okay, and both of these are vertical transformations. That's a vertical translation 2 units up. In the same way, that's a vertical translation 1 unit down. This is a stretch factor of 2 applied to the mother curve. Now the mother curve is y equals cos theta. Okay, and we saw previously, like for sine, we're going to first multiply and then we add or subtract. So first of all, we're going to transform the mother curve by applying the vertical stretch of factor 2, and after that we are going to translate it 1 unit downward. Okay, so let's just change these axes again. Let's go for 1, 2, and 3. Minus 1, minus 2, and minus 3. And your dots for cosine I'm going to put down for you. There's the critical points for the cosine curve. We're stopping at 270. Comes down to 90, goes to minus 1, and zeros again at 270 over there. So that will be, if we were to draw this in as a dotted line, that is where the mother curve is located, from minus 270 to 270. Now folks, like for the sine curve, if I continue to draw up to 360 here, the full cycle for cosine has been reached from 0 to 360. So the period here for both of these curves, the period will be 360. Okay, this is the point in the video where you pause and you draw those two diagrams, and once you've done it, unpause it and we will discuss it. Okay, let's see what you've done. You've got the cosine of theta in a dotted line. What do we do now? We add to all the y values of this cos theta, we add 2. So there the y value is 0, so we go 1, 2 up. It would be up there. Here the y value is minus 1. Plus 1 plus 2 would bring it to the positive 1 over there. Here it's 0, so it goes up 1, 2. Here it is 1, so it goes up 1, 2 to go and peak at 3. This is at 0, we add 2, so it lies over there. Minus 1 plus 2 brings us to that point, and then this one we add 2, 1 and 2, and we are finished at that point. So if I draw this graph now as a solid curve, remember it curves to the point, curves there, then it curves this way, it curves to the next point, reaches the minimum over there, and then goes back to 270. So your exit point is 270 degrees and 2, and your entry point is minus 270 degrees and 2. Your turning point lies at 0 and 3, and then 180 and 1 and 1, minus 180 and 1 and 180 and 1. So that's quite nice. It is the cosine curve that transformed by going up 2 units. Now, let us just quickly discuss the amplitude. Remember your amplitude, there's your line of rest. The graph is a maximum 1 away from the line of rest. Okay, let's go for this curve here. We're going to first sketch the green part before we transform it, just so that we don't lose track about what's going to happen. Here we're going to multiply by 2. The y value. So this y value stays. This one multiplies by 2, it goes down here. This y value is times by 2, it stays where it is. This 1 is times by 2, it goes up. 0 times 2 stays. Minus 1 is the y value. Times it with 2, it moves down. And then it goes to the 0 point back over there. Okay, so if I were to just draw this one, you never have to always draw this. It's just for you to see how these curves are transforming. So the dotted green line that I'm drawing in now is the transformed curve over here, the 2 cos theta. All the y values doubled. Now the final graph. is going to be where I'm minus 1 from each of those points. So this goes minus 1, minus 2, minus 1 is still minus 3, 0 minus 1 comes to negative 1, 2 minus 1 goes back to that point, 0 minus 1 is over here, and the cosine minus 1 is minus 2, minus 1 is minus 3, and that point we subtract 1 from its y value as indicated, and the point lies over there. Okay, so now the solid curve is the actual curve that I was looking for. It turns there, it turns back through that point, it turns at the bottom there, and then returns to the final point. So this here is y equals twice cos theta minus 1. Now folks, you can see from the horizontal line the maximum distance is 2. So for this curve the amplitude is definitely 2. Okay? For the curve that's dotted, which is y is equal to twice cos theta, let's look at that. There's the line of rest for that one. The amplitude is still 2. The period for all three of these graphs, 360. Okay, so this one here has the amplitude of 2 as well. And that was the point of that transformation. Okay, now I'm going to ask for a range now. Let's bring in some additional stuff. If I were to write down the range of the blue graph, the light blue graph here, if I want the range of that graph. Now we know the range are the permissible y values. Well, it has a minimum of 1 and a maximum of 3. So the range lies between 3 and 1. The range for the very dark green graph, maximum of 1, minimum of minus 3. So the range for this curve here, the y values will be bigger or equal to minus 3, but definitely less or equal to 1. The amplitude for this curve, as we said before, is 2. The period is still 360. Okay, and the domain over which we drew these curves was minus 270 to 270. Okay, folks, I hope that helped you. We're now going to change a bit and do graphs together, the sine and the cosine graph, in the next video.